Alright, so on part 2 now of weather and climate. Climate is the average weather you can expect, but it is not weather. For example, Toronto in January is normally cold and may have some snow, but it could be extremely cold and dry, or you may have a blizzard or sometimes even a warm spell. So, for example, in Toronto in recent times, the highest recorded temperature in January was 18 degrees Celsius, which is insane. And the lowest was minus 31 degrees Celsius. Whereas in July, the highest recorded temperature in June was 41 degrees Celsius. So June, sorry, not July. And the lowest temperature was 7 degrees Celsius. I remember actually as a kid there was snow in the spring once. Huge blizzard covered the car. So you can see the weather can change quite a bit just depending on the day, but the climate is your average. So let's move on to the next one here. Okay. Alright, so one way of looking at averages is to record what happens over a month and find the average, and then do that for like 30 years or more. And you can make something called a climatograph. So with this you record the temperatures and you record the precipitation. So for example, this red line graph here shows the temperatures for the year. As you can see, in the winter you're on average pretty cold. In the summer you peak, it's pretty warm. And then you can see your precipitation as well. So what they'll do is they'll get the rain and measure the millimeters of rain, or what they'll do is they'll take the snow and convert it to what that would be in equivalent for rain and put that in there. So what causes the change in the seasons is the Earth's tilt. In the summer, your part of the world is tilted towards the sun. In the winter, it's tilted away. And so we call these the solstice, the summer solstice and the winter solstice, which happen around June 21st and December 21st. So the shortest day is in December 21st, the longest day June the 21st. And then of course you have the in-between times, the spring and the autumn, where we have our equinox. Okay, so some factors that affect climate are latitude, because that affects your sunlight. You have more sunlight in the tropics on average than you do closer to the poles. Also, the sunlight is intense. It's concentrated at the tropics. It's not as spread out as it is at the poles. You got large bodies of water which act as moderators, so they keep the temperature from getting too hot or too cold. You have mountains which form relief, so that'll force air up where it cools and dries, and that'll affect the weather or the climate. Then you have elevation. The higher you are, the cooler it is. You've got the prevailing winds. Which directions do the winds normally blow? And you've got your ocean currents as well, which affect the weather and the climate. So you can take a look at these pictures here. These diagrams demonstrate some of the things that you have to consider when considering climate. Okay, latitude. So as you can see with latitude, in the winter you're not going to get as much sunlight compared to the summer, but in the tropics you're always going to get nice, finely concentrated light. It won't be spread out. Okay, large bodies of water. Large bodies of water, if you live near a lake, a bay, or the ocean, you'll get a sea breeze where, as you see in this diagram here, the land will warm up the air, which will rise up, and then it'll move out, and then the cool air from the ocean will blow in because it's heavier air, and then that reverses at night. Okay, as you can see right here. So the warm air blows out at night, the warm air blows in during the day. That's because the water and the ground change temperatures at different rates. Also, I forgot to mention, large bodies of water can bring lake effect snow and extra precipitation. So here's relief with the mountains. So what happens here is the prevailing winds bring the water, the air that's moist with the water that evaporated from the ocean. As it's forced up, the change in temperature forces the water to form clouds and then rain. And then when it gets over, all the moisture is gone, so now it's very dry air that comes down on the other side. And as you can see, we have these mountainous regions, the Rocky Mountains right here. Then we have the Appalachians right here, and that would affect whether we have relief. All right, elevation. As you can see, if you have extreme changes in elevation, you'll have a tree line. There'll be no trees past a certain point. As you go up, water actually even boils at below 100 degrees Celsius. And you can see how the temperature may change. If it's 10 degrees at sea level, when you're up 200 meters, it'll be 8 degrees. 400 meters, you'll be at 6 degrees. And when you make the summit, it might be like minus 3.5 degrees at this one particular place in Scotland. Okay. And why is this? This has to do with the ideal gas law. The pressure times the volume is equal to nR and then T, the temperature. So as your pressure changes, your temperature changes. Okay, prevailing winds. These are caused by the temperature differences in the atmosphere. So you got your cold air masses forming in the polar regions, and you have your warm air masses forming in the tropics. And this causes a convection cycle. But then at the same time, the Earth is spinning. So instead of just going straight north and straight south, this causes the air masses to curve or turn as they're moving. So here you can see some of the common prevailing winds. So for example, here in the Pacific, you've got the westerlies. You've got the doldrums, where it's pretty. If you're near the equator, there's not a lot of wind, so they call it the doldrums. Something you don't want when you have a sail ship. You got the westerlies, the southeast trade winds. Okay. So for example, back in the couple hundred years ago, if you wanted to take a boat from England to North America, the best thing would do is come south of Spain, catch the winds over here by Africa, come over to South America, come up into the Caribbean, and then when you want to go back, you come up through North America, and then by Nova Scotia, you catch the wind and blow you all the way back to England. Here you can see where we live. We have wind blowing from the northwest, so most of our weather comes from the northwest. Not always, but just most of the time. Lake effect snow, as I mentioned before, it's caused by prevailing winds blowing over large bodies of water. So for example, here in Barrie, Ontario, we have Georgian Bay to the northwest, and the prevailing winds come from the northwest. So that blows in extra snow, and so we're in the snow belt. We have lots of skiing. If you compare Toronto, Toronto's on the northwest side of Lake Ontario. So the prevailing wind leaves Toronto, hits Lake Ontario, and then it ends up in Buffalo. So that's why Buffalo always has more snow than Toronto on average. Not quite this bad though. Yeah. The other major factor for climate is the ocean currents. So, for example, there is a warm surface current from the Caribbean that comes up along the coast and then hits Europe. So this means that even though London, England, is further north than Ottawa, Ontario, as you can see, London's at 51.5 degrees latitude, and Ottawa's only 45.4 degrees latitude. 6 whole degrees latitude difference. Ottawa's colder than London in the wintertime, and the reason for that is the warm Gulf Stream coming up. So if you take a look over here, you can see some of the major currents. You got the Gulf Stream, you got the Canary Cold Stream coming here, and there's a few others as well. So air masses and fronts. A geological region tends to produce certain types of air masses, like you get a lot of cold air masses up in the polar regions. As you can see right here, okay, and here. And you'll get warmer air masses in the tropics, like right here and right here. And they'll run into each other. And when they run into each other, you get fronts. So the edge of the air mass is called a front. There's 4 main types of fronts. You got a warm front. This is when a slow-moving warm air is replaced by cooler air. When the air is replaced, the warm air will take over in the end, and it gets warmer and more humid. This may cause some rain, and that's the symbol you might see on a weather map. Here's a cold front. Here's when fast-moving cold air comes into contact with warm retreating air. After the front moves through, the temperature and humidity decreases. Rain normally comes with this. You get violent weather, maybe you get a thunderstorm. Stationary front, this is kind of when the air masses are not moving. And there's a boundary between the cold and the warm air masses. Could be warm or cool for a long period of time, maybe some long prolonged rain. And then you got occluded fronts. This is when the warm front is taken over by the cold front, and you end up getting periods of rain. Okay, so biomes. Biomes are regions with similar land, food webs, and climate. So for example, here in North America, we got the tundra where it's almost always cold. You have permafrost. You've got the taiga. That's where you have coniferous trees like pine trees, spruce trees. Then you've got where we live, temperate deciduous forests. So we've got conifer trees, and we have all the other kinds of trees as well, like oaks, maples, hardwood trees, you name it. You've got the grasslands in the middle, where it's pretty flat. There are forests, but there's also a lot of grasslands. Desert, dry areas. You got your temperate rainforest right here. And these are the main biomes in North America. But there's lots of biomes in the world. You got the polar regions, tundra, taiga, montane, alpine tundra. Okay. Mixed and deciduous tropical rainforests, which we don't have here, unfortunately. The steppe, where it's very hilly, mountainous. Okay. You got savannas, extreme warm grassland areas, which also dry out a lot. You got deserts like the Sahara right here, and you got Mediterranean vegetation areas as well. And there are other smaller names for other types of biomes. Alright, in summary, weather is the day-to-day conditions, and climate is the long-term average conditions. So weather is measured immediately, fluctuates greatly, and it changes quickly. Climate is measured long-term. You got your average data, and it changes slowly. And in either case, you're interested in temperature, precipitation, your wind conditions, your humidity, and your air pressure. And I hope this helped. Take care.